Good afternoon, everyone. I'm delighted to be presenting at this EmpowerED seminar. My name is Tim Drysdale, and I'm the Director of Strategic Digital Education and Chair of Technology Enhanced Science Education in the School of Engineering at the University of Edinburgh. Now, today I'm actually travelling in rural Scotland, so this is a slightly older version of myself from last night speaking to you, just so that you get the best video quality possible. I'm very much hoping to be here for questions. You may have already heard me speak. Right, let's bash on with talking about remote labs. So we started doing remote labs at the University of Edinburgh before the pandemic because we have quite tight campus space. We have some limitations on class sizes there. But during the pandemic, we really got a good start on rolling them out, and our Generation 1 boxes were these fabulous laser cut boxes, and they were the ones that we first used on our third year controls course. Come 2022, we obviously wanted to expand into foyer spaces, so we got maximum real estate value from them, and to do that we needed metal boxes that were fume tight to keep any possible fumes from short circuits in circuits all inside the box for safety in these public spaces. So we did that together with our Central Estates Department, and the result is that we've got these fabulous metal shipping containers, a bit of a nod to the fact that we're transporting or shipping the experiments to the users, although obviously online rather than with a boat. How does it work? Well, we've got a cloud infrastructure that we've built from scratch to deliver on the needs that we have at the University of Edinburgh. And it makes it a lot easier on the IT team and on the teaching team, support team, because everything just runs through a browser, so there's nothing to download, there's no issues around what computing device somebody wants to use, so long as it's capable of running a modern browser. And our experiments are easy to install as well. They just act as bring your own devices. They have no special privileges at all. So far, we've used them for timetabled activities. We've also used them for independent tasks. We've used them for demonstrations. And I've even put them into a recent proposal as a route for disseminating research. It's a big team that's involved in this. We're cutting across a lot of different organizational boundaries. We've got academic staff, professional services staff, technical staff, PhD researchers. There's a huge number of people that have been involved in embedding these into our systems, and I'm grateful to all of them for their contributions. Obviously, there's a couple of critical pressures on teaching. I mean, we could list a lot more, but the main categorization at a very coarse level is that we've got to keep going, and for some organizations that means growing as well. We also need to respond to external change. You know, a good half century of practice has been tipped on its head with large language models. What are we going to do about that? Well, I've got a bit of a hint for you on that one. So let's look at where we are now, though. This is what I remember from my undergraduate days, and this is what I see as a staff member when I'm in a corridor outside a traditional lab. It's absolutely packed. But do you know, how busy are the labs really? You know, how much are we actually putting on our courses? You know, the labs are completely full, but when we analyze our courses, and this is some data that I won't attribute to any particular university, but I happen to be able to find it by scraping some public data sources that were in a very convenient form, listing all the different types of things that were going on in the courses and the hours associated with them. Obviously, without access to enrollment data, I couldn't weight the experiential learning in the mandatory courses perhaps as highly as it might be, but it was interesting to see it come out at 3%. I'd really like to see that sort of number at many universities hit 10 or 20 times that, come in at 30%. And we could do that by carry on doing all the good things that we're currently doing and providing new opportunities for students to work independently with remote labs, for example. Of course, if we wanted to try and build that sort of increase in practical and experiential learning in traditional manner, then we'd be looking at a very, very, very significant investment indeed. And a couple of universities that I know have done this kind of thing have invested, it's just an immense amount of money, and even then, it's very difficult to achieve the kind of numbers that we're talking about. The alternative, of course, is to embrace some modern methods, and if you have equipment that's available online and it doesn't take up as much space, and the space that it takes up is much cheaper to run and operate, then really it's available for many more hours, and students can have access to equipment with a smaller ratio of students to the number of pieces of equipment. And you can set the group size for pedagogical reasons rather than for resource-based reasons. And if we throw some numbers at this to get some kind of idea, it starts to look quite staggeringly large. The saving that you can make, a single square metre in a foyer is a lot less expensive than 150 square metres of teaching space that's been decked out with equipment. So there's a real cost saving to taking this approach. And you get to add value to existing real estate. Foyer spaces and buildings are often an opportunity for an enhancement in the aesthetic value, adding something interesting that your visitors, that your guests can see, whether they're staff or students or industry members. Make your teaching, make your research visible. Some examples of what we've done include a third-year controls class with around about 250 students. We started off serving them with around about 12 experiments, but that was pretty small number. It turns out for a good experience, you really do need closer to the rule of thumb, I reckon, around about, for most delivery mechanisms, that's around about 1 experiment per 10 students. So we've since expanded this set significantly for work on another class. But we went from groups of 6 working in 3 hours in total in groups of 6, so that's equivalent of about half an hour one-to-one time. Even though that's a bit of a kind of KPI-ish metric, it was just one way of showing you the the increase in access that remote labs give you. When we let the students have all-you-can-eat access to the remote labs, even though we only had 12 bits of kit on this particular first year that we tried it, the students used around about 10 hours each. So we were looking at a 20 times improvement in the number of practical work hours that were given to the students on the course. Now, for our first year class of 450, well, how did we come up with a class of 450? Well, to start with, we have 4 strands of engineering. And what we wanted to do was bring them together in a common first year so that we could introduce them to the various engineering habits of mind and so on. And that quickly outstripped the capability of our campus to host them for even for lectures, let alone practical work. So remote labs were instrumental in providing practical work to this large class. And we hosted the sessions in a classroom. It was timetabled. There were staff, tutors and demonstrators and students there working together and able to talk with their peers, talk with staff and undertake the exercises. So that was a great way of helping out with our curriculum change. We've got a bunch of other experiments as well. We've got some structural beams that we use for civil engineering and structures courses. We have some electromagnetic analysis kits with 1-port and 2-port systems with auto calibration that we've been developing for use on some 3rd, 4th and 5th year courses. We have a variety of spinning things that help with controls, and we've got some new experiments coming in the area of electronics and also chemical engineering. For 2023, the 3rd year that we've been running these with courses, I added a new booking system to let students book in advance and to cancel their bookings. And these required some upgrades in the background of the system as well, but we've seen in the data that this has improved the students' impression and experience of working with equipment. So it turns out that all of these things are important, and it's not just the experiment design itself, it's also the rest of the system has to support the kind of teaching that you want to do. And we're happy with where we've got to with that now, and obviously continue to make developments in areas of the system as is indicated by the data that we collect. Looking at a UEQ, or the student responses, using a standard approach to understanding how people are feeling about technology. We looked at the 2 controls classes in year 3, and the 2023 data there is for the larger class of 450. Generally, everything is positive. In the first year, we had very limited equipment. It was during the pandemic. The dependability was just neutral at that point. But since then, when we added more kit and then added the booking system, that dependability score has come back to being positive. Interesting, the novelty was very quick to fall off, but you talk to almost any student and it's almost surprising, but it probably shouldn't be, just how unsurprising it is to them that we would hook equipment up to the internet. So I think that's both heartwarming and also just a bit of a prompt that this is not going to be particularly provocative for a student to be accessing something online when they assume so much else of their life is online. So, and that's okay. The novelty factor here is less important to us than a number of the other aspects that we've been exploring. One of those is the perception of skills practice. So students find a number of things easier with remote systems. There's a bunch of things that are important that they really don't see any significant difference between them and a proximal or a physical lab where they're there in person. These of course are physical labs with real equipment that are done remotely, so it's really all about the location of the equipment, and hence the term proximal. And there are a couple of things that are considered easy with proximal, such as designing your own experiment and potentially working with others. But this data was collected from students who were working at home during the pandemic era. And now that we've done some work in classrooms with students working together with staff, we'd expect to see that reflected in the data as well. A sample of some student comments. It's been really well received by students. And one of the key things that's really great to see here is that students are wanting to play and explore. Obviously, there's a risk of grade polishing, so there's some further work to be done just to make sure that we're supporting students in doing the right amount of work. This is not a social media system where we want to try and entice people in. So, one of the conversations that often crops up is around gamification and so on. And, we're not trying to drive people to do anything more than their curiosity-driven and, interest-driven work in the science. We don't want to try and add anything else to that at this stage, but it is an interesting ongoing conversation. Some more comments were around the accessibility and the widening participation aspects of having time to figure things out at a pace that suits you. As we know, laboratories that are scheduled on campus can be very, very rushed. When timing is tight, when classes are large, and when there's a lot going on. So having that freedom to slow down and take it as you want to has certainly been welcomed by students. So that's all about solving the instrumental challenges around campus estates. There are some external factors about the future of education. I talked about 500 years of practice being turned on its head. What are we going to do about these large language models, for example? Well, even before the AI crowd jumped on the scene and gave us all a bit of a fright, there were a number of people, myself included, who are already asking questions around what is it that we should be doing as we look to the future. And there are a variety of strands here. A straightforward one to talk about is the authentic assessment piece around doing assessment that is going to drive students to learn the things that we would really like them to learn. And I do sound a small note of caution here on behalf of a colleague of mine at Edinburgh, Gert Biester, who gave us a great talk at our recent Learning and Teaching conference around the idea that just because we can measure stuff, we shouldn't fall into the trap of valorizing only the things that we could measure, and that we shouldn't treat education as a causal machine, but instead we should treat it as an open, semiotic and recursive system. So, there's quite a lot still to learn here, but the really great thing I think about these digitally mediated activities such as remote laboratories is that it opens up a new door to us doing some pretty interesting things. Obviously, with artificial intelligence coming along, it's entirely possible for students to produce outputs, and we tend to have, or produce those outputs with AI, and we do tend to have many assessment systems that rely on simply measuring outputs. Yet we know that there's a process that's there, and that the process is actually a really important part of what we're doing. But it's often been really expensive to have people in a class with staff go through an iterative process and touch that iterative process and assess it at each stage in the iteration, because those iterations might be happening at different timescales across the class, and every submission cycle is a fairly heavyweight process. So in a traditional setting, assessing iteration is really challenging. Yet, when we have a rich data stream from a digitally mediated activity like remote laboratories that is addressing an authentic problem with real equipment, then we have access to a data stream that can show perhaps some iteration in students' thinking, and we can extend this idea in a number of directions perhaps. We can also look at feedback on demand, which is important because learning does require some discomfort. Now, we don't want so much that students become frustrated. We don't want to make things so easy that students become bored. Somewhere in the middle is that transition from confusion back to flow, and that's where the learning takes place, when you make those transitions. So we've been doing some work. My student David Reed's been doing a fabulous job here. We've recently submitted a paper that shows some really promising results in this area of providing feedback to students, and I look forward to being able to talk a bit more about that when we're into the publication process a bit further. So, summarising, the benefits of remote labs are that they're going to let us prepare for future developments by providing that rich data stream and opportunities to look at authentic assessment and incident feedback and a number of other areas in their exploration. But basically, increasing the experiential learning drives us in a good direction. And of course, there are far more immediate benefits as well, in that if we just straightforwardly want to increase the amount of practical work, well, it's the same system, and it's very cost effective compared to building new buildings, and also you can set them up a lot faster than you can procure and build a new building. So you might be thinking, this is great, how do I get hold of it? It's a really important part of the equation to us that what we've been learning how to do, that we can share with you as well. And obviously the teaching that we like to do will vary from location to location, country to country, and so forth. So an open source approach allows that customization and modification to suit your local requirements much more energy efficiently than having to deal with a proprietary system. So all of the code we've produced so far is open source, and my school is very, very keen to address the sustainability piece by having us work with other universities to help them share the same benefits that we've been experiencing. So an absolute green light to get in touch and see what we can do to help you out. If you know everything about running stuff in the cloud, then our code's there. You can download our hardware designs, you can get building, you can just off and go. If you'd like a little bit more help with that, we'd be delighted to have a chat. And with that, I bring the formal part of the conclusion to close and hand over to my future self, who hopefully is able to join this call with some of the rural Scottish broadband. So thank you very much.